Hello everyone, this is K. Faraj Sheikh from CSMB. Today's my topic is minimum spanning tree in descriptive mathematics. So let us start our topic. Here is the outline of our presentation. Firstly, give the introduction of graph theory and we discuss about what is spanning tree and further we'll discuss about what is minimum spanning tree and we will discuss about minimum spanning tree properties, its applications, and we'll discuss the problem statement and greedy algorithms for minimum spanning trees, and at last we'll conclude them. What is graph theory? Graph theory is a study of graphs, which are mathematical structures used to model relationships between pairs of objects. A graph consists of vertices connected by links. Graph can be directed or indirected. Key concepts include paths, cycles, and connectivity. Graph theory has applications in computer science, biology, and social sciences. Now let us discuss about what is spanning tree. A spanning tree is a subgraph of the connected graphs that includes all the vertices with the minimum number of edges and no cycles. For a graph with v vertices, a spanning tree has v1 edges, making it connected and cycle-free. Spanning trees are used to optimization problems, network assign, and algorithms like Kruskal and prisms to find minimal connections. Let us discuss about minimum spanning tree. A minimum spanning tree is also known as MST of a weighted graph in a spanning tree that connects all vertices with the minimum possible total edge weight without any cycles. It commonly used in network design to minimize costs. Algorithms like Kruskal and prisms are used to find a minimum spanning tree. Let us discuss the properties of minimum spanning tree. Minimum edge weight, uniqueness, vertices and edges, cut property, and cycle property. These are the properties of minimum spanning tree, and let us discuss few applications of minimum spanning tree. Network design, approximation algorithm, and cluster analysis, imagine segmentation, pathfinding and routing. These are the applications of minimum spanning tree. Let us discuss about Kruskal's algorithm. Kruskal algorithm is a greedy algorithm used to find minimum spanning tree of a connected undirected graph. It constructs the minimum spanning tree by repeatedly adding the smallest edges while avoiding cycles. Here how it works. Sort all the edges. These are the steps of Kruskal algorithm. Sort all the edges of the graph in ascending order in their weights. Initialize an empty set of the minimum spanning tree edges. Process each edge in order. Stop once the minimum spanning tree has edges where is the number of vertices. Let us take an example. For a graph with vertices and edges like a comma b comma c and b comma c comma 1 and a comma c comma 4, Critical algorithms would add edges in order of weights, ensuring that the tree remains connected and cycle free, resulting in the minimum spanning tree. So this is the solution of the problem. Here is the critical algorithm to find the minimum spanning tree. First, choose the arc of a least weight. Second step is choose from those arcs remaining the arc of least weight which do not form a cycle. And the third, repeat the step 2 until n minus 1 arcs has been chosen. So let us discuss about Prim's algorithm. Prim's algorithm is a greedy algorithm used to find minimum spanning tree of a connected, undirected, weighted graph. It builds the MST by starting from an initial vertex and repeatedly adding the minimum weight edges that connects the tree to a new vertex. Steps of Prim's algorithm. Choose a arbitrary starting vertex and add it to the minimum spanning tree. Initialize a set to keep a track of vertices including in the minimum spanning tree and a priority queue to store edges based on their weights. Repeat the following steps until all vertices are included in the minimum spanning tree. Continue until the minimum spanning tree spans all vertices. Let us take an example. For a graph with vertices a, b, c starting from a, the algorithm picks the smallest edge connected to a. It continues by adding the smallest available edges at each step, expanding the minimum spanning tree without forming cycles and producing a minimum spanning tree. So this is the solution of the problem by Prim's algorithm. So let us conclude our topic. Minimum spanning tree algorithms, specifically Kruskal's and Prim's, are vital for efficiently connecting all vertices in a graph with a minimal total edge weight. Kruskal algorithm excels in sparse graph by adding the smallest edges without creating cycles. Prim's algorithm is suited for dense graphs, expanding from a starting vertex by selecting the minimum adjacent edges. These algorithms have broad applications in network designs, clustering, and path optimization, making them essential tool in graph theory and practical problem solving. So this is all about my topic, minimum spanning tree. So thank you for giving me this golden opportunity.